In this session we shall see the analysis and design of pre-stressed concrete Girder bridge in AASHTO LRFD standard. The ASTRA Pro main screen is opened, select menu item file, then select working folder. As the selection box comes, user may use the button browse and select folder work on the desktop. Next, select menu item file, then select bridge design and further select pre-stressed concrete PSC I-Girder bridge. Then select limit state method, then select AASHTO LRFD standard. As the window opens, the span is mentioned of length 110 feet. The various analyses data are given as default, crash barrier is considered on one side only. The various tab pages of the window for various details are for individual tasks related to the analyses of the grillage model of the bridge superstructure. The design job number is 1, click on button New Design, message comes as the project is created as design job number is 1. The next tab page is for general arrangement diagram of the deck and girders. In the page for section properties, there are 3 more tab pages under this tab page. These are long main girder inputs, cross girder inputs and summary of member properties. The current tab page is long main girder inputs. The various dimensions of the girders as interior beams and exterior beams are given as default data. In tab page cross girder default inputs are given for cross girders. In tab page summary of member properties, the calculated values of section properties are shown for long girders as well as for girder with applicable width of deck slab. In the tab page moving live load data, the various combinations LRFD HL93 truck loading is applied lane-wise on the bridge deck. On the left panel the load 1 is with single lane loading and in load 2, 2-lane loading is applied, which user can modify it as desired. The load type 1 is applied, which is for LRFD HL93 truck loading. Selecting the moving load 2, click on button View Moving Load to view the moving axles on the grillage model. Each increment of movement is mentioned as 0.5 meters, which is generating a load case for each increment of movement, and the analysis will be done to obtain forces as bending moments, shear forces for each load case. Finally, the maximum forces will be extracted for the design. In the page analysis normal process there are 2 more tab pages under it. Currently the tab page analysis data is opened. The end supports are mentioned. Click on button Create Analysis Data, the message comes mentioning that the analysis data are created. Then open the tab Page Process. In Page Process all the 5 analyses input data are listed. Next, click on button Process Analysis, the list of all 5 processes are displayed. Click on button Process to start the process. As the process starts the dialog box comes to verify the analyses data, click on button Proceed. As the data check is over and load cases are obtained the message comes, click on button OK. Next the dialog box comes to process the analysis input data, click on button Proceed. The analysis will be done and the message comes informing that the report is created. Click on button OK. This completes the first process of total 5 processes. The other processes in the list are all processed one by one, and finally the reports of all the 5 analyses are read to get the maximum member forces at various points of the bridge superstructure and maximum reaction forces at the supports required for the design of bearings, abutments, and piers. Hence the basic main analysis is over. By selecting an analysis data from the list and by clicking on button View Pre-process, the GUI is opened, where user may view the structure as per the selected analysis data selected. Next, the tab page Deck Slab is opened. The various design data are displayed in the page which user may modify. Click on button Process for new design. The Excel worksheet opens with the design of RCC Deck Slab. View the tab sheets for different parts of the design. User may also change any input data directly in the Excel worksheet and the design will be revised accordingly. After viewing, close the Excel worksheet. Next, the tab page PSC I-Girder is opened. Click on button Process for new design. As the worksheet opens, the various tabs at the bottom of the worksheet may be opened to check various steps of the design. View the tab sheets for different parts of the design. User may also change any input data directly in the Excel worksheet and the design will be revised accordingly. After viewing, the worksheet may be closed. Next, the tab page Abutment is opened. There are some data in the tab page which user may change as desired. These are general data. Click on button Process for new design. The Excel worksheet opens. There are various tab sheets at the bottom for various aspects of the design. In these tab sheets any input may be changed by the user and may be checked for its effects. After viewing, close the Excel worksheet. Next, the tab page Pier is opened. There are some data in the tab page which user may change as desired. These are general data. Click on button Process for new design. The Excel worksheet opens. There are various tab pages at the bottom for various aspects of the design. In these tab pages any input may be changed by the user and may be checked for its effects. After viewing, close the Excel worksheet. Next, the page for bearing is opened. Click on button Process for new design. The Excel worksheet opens. There are various tab pages at the bottom for various aspects of the design. In these tab pages, any input may be changed by the user and may be checked for its effects. After viewing, close the Excel worksheet. Next, the page for drawing is opened. By selecting the desired button, the set of sample drawings are opened in ASTRA Viewer CAD for necessary editing and saving either as DWG or DXF file. Upon finishing, user may close the CAD window. This is the end of the session for the design of the PSC I-Girder Bridge. You may write to techsoftinfra@gmail.com or techsoft@consultant.com. Thank you.